This video describes methods added to Statgraphics Centurion version 17 for creating ternary plots. Ternary plots are a method for plotting three variables which sum to a constant. They're used in many fields to display the composition of mixtures of three components. Ternary plots are also called simplex plots or di Finetti diagrams. As an example, the file grit.sgd has data for 56 batches of grit. Each row of the file shows the percentage of large, medium, and small particles in a particular batch. The data are from Holmes and Mergen. I've loaded the data in the grit file into the Statgraphics Centurion version 17 datasheet. The first thing I'm going to do with this data is create a typical three-dimensional plot. I'll do that by going to Plot, Scatter Plots, XYZ Plot. I'll put the large values on the Z-axis, the medium values on the X-axis, and the small values on the Y-axis. Taking the defaults, you'll see that it will create for me a typical three-dimensional plot. As I rotate this around a little bit, you'll notice that all the points actually lie on a plane in the three-dimensional space. That's because the values in each row of the file all sum to 100. In fact, not only are they constrained to lie on a plane, they're constrained to lie on a triangular plane within this three-dimensional region. Now let's create the ternary plot. I'll go back to the Plot menu to Scatter Plots, but this time select Ternary Plot. I'll make the large column component A, I'll make medium component B, and I'll make small component C. I could also specify a fourth column to code the points by, but in this case they'll all have the same point symbol. When I press OK, it will ask me what value I want to use for the minimum of factor A, the minimum of factor B, and the minimum of factor C. It'll also ask me how many tick mark divisions I want along each of the axes. For the moment, I'll just press OK and take the defaults. Here you see the basic ternary plot with the 56 batches all plotted on the triangular region. Every position within this triangular region represents a location where small plus medium plus large adds up to 100. The way you read the axes are the following. Small equals 0 is the left side of the triangle. This line here is small equal 20, this is small equal 40, small equal 60, small equal 80, and this vertex is small equal 100. The right side of the triangle represents medium. Medium equals 0 is along the right hand side. This line here is medium equals 20, medium equal 40, medium equals 60, medium equal 80, and at this vertex, medium equals 100. The horizontal lines give the axes for large. The bottom part of the triangle corresponds to large equals 0. This line is large equal 20, large equal 40, large equal 60, large equal 80, and the top vertex are locations where large equals 100%. Because all the points are located close together in the bottom left corner of the triangle, it's useful to go back, click the right mouse button, and access analysis options. If I set the component B minimum to 75 and press OK, it will expand the triangle to give me a better view of my points. The minimum value for medium has now been set to 75. At the same time, the maximum values for large and small have been set to 25. Incidentally, if you want to see the coordinates of any point, you can just hold the left mouse button down, and in the upper left corner of the plot, you'll see that that's row 26. Large is 7.3%, medium is 79%, and small is 13.7%. One other point to mention. You'll notice that the tick marks on each of the axes increase in a counterclockwise direction. Along each of the axes, as I move counterclockwise, the tick marks go from smallest to largest. I can change that behavior by going to the Edit menu to Preferences and accessing the Graphics tab. There's a checkbox down near the bottom of that dialog box where I specify whether I want the ternary plots to be counterclockwise or clockwise. Some people like them one way, other people like them another way. I should also point out that version 17 of Statgraphics Centurion is not the first version of Statgraphics to create ternary plots. The experimental design wizard, which was added in version 16, also uses ternary plots to display mixture experiments. This ternary plot, for example, shows a typical simplex centroid design created to study the effects of binder, fuel, and oxidizer on the burn rate of a rocket propellant. Each of the points shows a combination of these three components at which an experiment would be performed. The Design of Experiments wizard also uses ternary plots to display the estimated response surface when analyzing a mixture experiment. Here, you'll see a typical contour plot for the rocket propellant example. The colored regions represent the values of burn rate as a function of binder, fuel, and oxidizer. You'll see that in this estimated response surface, there's a very well-defined maximum. We can also add one more dimension to the ternary plot if we want to display a fitted response surface. If I double-click here and look at this particular graph, you'll see the estimated response surface and the maximum burn rate superimposed over top of the triangular region. Ternary plots like these are very useful when you have three variables to display that sum to a constant.